Okay, welcome everyone to the award session at ISS 2020. I'm really excited to announce a number of awards this year, and so we'll guide you through this session. If you could advance to the next slide, please. We have an overview of the different awards. So we have the Best Paper Honorable Mention Awards, 4 of those. We have the ACM Europe Council Best Paper Award. Then there is the awards for Best Demo. There are actually 2 of them, one from the committee and one from the People's Choice, and the Best Poster. And last, we also have the 10-Year Impact Award. So we're excited that we have a short 5-minute talk from Ken Hinckley, and then we'll have a Q&A session with Ken right after. And these are the kind of different stages we'll go through. All right, next slide, please. So let me begin with the Best Paper and Honorable Mention Awards. I want to tell you a little bit about the process of how Best Papers and Honorable Mentions were selected, and then we'll announce the winners of this year's awards. Next slide, please. So the process for this year, there were multiple stages. So first, the recommendations from either the editorial board or reviewers could made recommendations directly for Best Paper or Honorable Mentions. We also took any paper where the impact was selected at the highest category. So that was significant impact from any of the reviewers. And we put all of those papers together, which was a set of 9 papers out of all the accepted papers. And then we formed a committee. We had the both editorial board chairs, so me and Fanny, and 2 of the associate chairs from the committee involved. And then every person individually ranked all of these 9 papers from before in a ranked ordered list. And then we made both selection out of those 4 different lists that were created and had several conversations about them to arrive at a final list of best paper and 4 honorable mention awards. And so best paper is always given to the top 1%, and honorable mention best paper together to the top 5%. And with those 5 papers, we're just slightly above 5%. So that was our choice. We could either have a little bit less or more. And because we're so excited about this program, we have 4 awards for honorable mention and 1 for best paper. Next slide, please. So without further ado, I would like to announce the Honorable Mention Award. So these are 4 papers, and I'll just go through them in order. So let's go to our first Honorable Mention Award. Next slide, please. So this award goes for exploring user-defined gestures for ear-based interaction from Yuchun Chen, Chiaying Liao, Xuwen S, Dayan Huang. And congratulations for your award. So you get a round of applause from me and probably many others virtually, remotely around the globe. Congratulations on the award. Next slide, please. The second Honorable Mention Award goes to the paper Towards Rapid Prototyping of Foldable Graphical User Interfaces with Flacto. The authors are Iyad Kadam, Jean van der Dongt, Salah Dovaji, and Donation Grolo. So congratulations to the authors again for your Honorable Mention Award. Not a big round of applause. I need one of those little remote triggers so I can trigger a round of applause. Okay, congratulations. That was our second. Now the third one, the award goes to combating the spread of coronavirus by modeling for mites with depth cameras, and that goes to Andy Wilson. Congratulations. The third one. Thank you. I'm not sure who's playing this, but we have the round of applause there. Joachim, I think. Thank you. All right, and we have one more. The last Honorable Mention Award goes to VibHand On-Hand Vibrotactile Interface Enhancing Non-Visual Exploration of Digital Graphics. The authors are Kaijing Zhao, Marco Serrano, Bernard Aurelio, and Christophe Jouffre. So congratulations on your awards to all 4 winners of Honorable Mentions. Okay, Again, big round of applause. Congratulations. We now move to our winner of the Best Paper Award. And for this, I would love to hand over to George, who will introduce the winner and also talk about the award. So, George, I can see.
Thank you very much, Nikolai. So next slide, please. Great. So first of all, I would like to thank every author of this conference, okay, for making that a very successful conference, and all of the people that they worked really hard, okay, the organizing committee, the program committee. And I would like to especially thank Nikolai, Joachim, and Fanny for inviting me also to present the paper. This paper is sponsored by ACM Europe Council, okay, the Best Paper Award. So next slide, please. I have to tell you just a few things about this. Okay, since 2016, the ACM Europe Council sponsors Best Paper Awards that they are trying to recognize authors of outstanding technical contributions to ACM conferences that they take place in Europe. And every conference from ACM that takes place in Europe is eligible. And the recipient of the award is chosen based on the evaluation criteria determined by the program committee that this conference has. Next slide, please. So what is the Best Paper Award? Each of the authors of the best paper will receive a plaque from ACM. In addition, there will be 1,000 euros honorarium to be split among the co-authors. They will decide how exactly they will split the money. And moreover, the recipient paper will be provided online through the ACM Europe Council Awards page. So you will have increased visibility, and all expenses, of course, related to this award are covered by ACM Europe Council. So next slide, please. This year, okay, we are going to give the award to your conference, okay, the Interactive Surface and Spaces, regarded as one of the most important conferences that took place in Europe, okay, and it was organized by ACM. So I will do a small spoiler now. Next slide, please. And then I will announce the winner. So we received from the committee that ended up with this as the most outstanding paper. They said they commented that it was an outstanding paper praised by reviewers and committee members and selected by this independent panel for its high quality of research, presentation, and contribution to the interactive surface and spaces community. The research of auditory workspace awareness for visually impaired users during tabletop interaction is a creative idea and thoroughly studied in the presented work. The work addresses the core interest of the community in interactive surface and spaces and well deserves the award of best paper. So the winner is, next slide please, the paper Collaborative Tabletops for Blind People, the Effect of Auditory Design on Workspace Awareness. Congratulations to all of the co-authors, Daniel Mendes, Sofia Reis, Joao Guerreiro, and Hugo Nicolau. Well done, excellent, good job, okay. Congratulations, guys. I don't know if we have the authors attending, any of the authors at least. But ACM headquarters in the next few days, okay, they will contact them. I have the contact of Daniel Mendes, and they will arrange the details of how they will get the plaques and the money. Congratulations once more, okay, and thank you very much for the honor to be here in this conference. I wish, and I believe that we all wish, okay, we were physically there in Lisbon, but
thank you so much, George, for awarding the Best Paper Award. Congratulations to the authors also from my side. And I'll now hand over to Fanny, who's going through the Best Poster and Best Demo Awards. Next slide, please. All right.
Yeah, parabéns. I see in the slide parabéns in Portuguese to all of the authors for the honorable mention and Best Paper Awards. Now it is my pleasure to present the Best Poster and Best Demo Awards on behalf of the respective chairs. So the Best Poster Award was a combination of votes from the poster attendees as well as the jury selecting the best poster. And without further ado, the winner is Smart Elevator Hall, a prototype of in-building guiding using interactive floor display by Takashi Matsumoto, Motoaki Yamazaki, Yuya Igarashi, Ryotaro Yoshida, and Mishihito Shiraishi. Congratulations to all of the co-authors of this poster. Thank you, Joachim, for the round of applause sound. Honestly, like a coffee machine in the background from my end. Congratulations.
It's the whole of Wembley State applauding here.
So congratulations to the poster. Next slides, please. Now we're moving on to the demos. I still see the poster slide at my end. Can we move to the next? Thank you. So the best demo awards, we have two awards. One which is the choice of the attendees, the People's Choice Best Demo, and one that was selected by the jury, composed of the demo co-chairs and I believe another selection of jury members. So the first one is a People's Choice Award. Next slide, please. That goes to combating the spread of coronavirus by modeling fomites with depth camera. So congratulations to Andy Wilson for the People's Choice Best Demo. And the best demo goes to, next slide please, Project S-Key, enabling high-fidelity augmented reality on an open-source platform by Damien Rompapas, Daniel Quiros, Charlton Roda, Brian Brown, Noha Zerkin, and Alvaro Casinelli. Congratulations for the Best Demo Award. So we wish we could award a lot of, more awards. All of the program was very exciting, but congratulations again to all of the awardees for the best demo, best poster, honorable mention paper, and best paper. And now we're going to move back in time and discuss a little bit some of the work from previous years at ISS. So we have the pleasure of having a 10-year Impact Award, which basically recognizes the work published at ISS 10 years ago, which was ITS back then. That work that has been particularly influential since its publication. So not to hold the suspense, the award goes to, next slide, please. Please reveal Code Space, Touch plus Hair Gesture Hybrid Interaction for Supporting Developer Meeting by Andrew Bradgun, Rob Deline, Ken Inkley, and Mary Morris. Congratulations to all of the co-authors for this work Code Space, which has inspired and influenced several works focusing on mid-air and touch interactions at ISS, but also in beyond ISS, in all of the HCI relevant venues. So a lot of work has been published at CHI, WIS, UbiComp, and more, bearing inspiration from Code Space and insights shared in Code Space, but also beyond HCI. The work has also contributed to future advances since then in agile software development, particularly in many fields such as artificial intelligence, software visualization, automotive UI design, and more. So we are very pleased to recognize this work, and without further ado, listens to Ken Inkley talk, who is going to look back at the work and discuss how this contributed to shape future ideas, and we'll have a short presentation. Yeah, we can clap. A short presentation by Ken in the form of a video, and then a long time to discuss and ask questions to Ken about this work and more. So congratulations, everybody, and we can now play the video from Ken.
I'm Ken Hinckley. I'm very excited to be here with you today, and I'm very humbled to accept this 10-year Impact Award on behalf of my co-authors, Andrew Bragdon, Rob DeLine, and Meredith Ringel-Morris. I'd really like to thank the organizers for this honor, and of course the whole ISS, Interactive Surfaces and Spaces community. This is a good example of one of those papers that makes an impact, even though it explored a space that was not in itself totally new. I know this very well because reviewer 2 alerted us to this shortcoming in a few choice words. It's the basic idea that devices should better leverage the space in between, that is, the empty space between multiple devices, as well as the surrounding context. Projection systems, going back to Rekimoto and Saito's augmented surfaces work, for example, lit up these spaces in some ways. And even earlier, the classic Put That There experimented with this notion as well. The introduction of the Kinect offered a pragmatic and plausible way for semi-fixed features like wall displays to sense these spaces in between. It ended up sparking a lot of work on rich spatial depth sensing, without requiring markers on people and devices. This pushed these frontiers further, including CodeSpace. CodeSpace took this notion of spatial input and looked at how hybrids of touchscreen input and device orientation could combine. It also had this sensing aspect that always interests me, with presence detection, as well as in-air gestures for deictic reference. And all of this across multiple interactive surfaces and spaces defined by the small device ecology of mobiles, laptops, and electronic whiteboards nearby. So this seems as good a place as any to dive in and show you a quick supercut of what CodeSpace was about.
CodeSpace enables cross-device interactions, or multimodal input techniques that combine in-air pointing and postures, physical proximity, direct touch input, and motion sensing input channels together into a single interaction. Many development meetings focus on categorizing or prioritizing a set of items, such as bugs. CodeSpace builds on the code bubbles visualization metaphor, in which individual methods, bug reports, sticky notes, and diagrams are displayed in individual bubbles that can be moved and manipulated with touch. Our goal is to allow developers to easily bring digital artifacts into a whiteboarding experience and then annotate them as needed. When an audience member points at the display, skeletal tracking identifies a gesture and displays a cursor on the shared display, allowing them to point out precise locations to the group. Audience members can also manipulate objects by forming a flat palm posture with their hand. Objects under the cursor will now be dragged with the user's hand motion until released. Audience members can also use a mobile phone to interact with the shared display. Users may point the phone at the display much like a remote control, showing a cursor. To drag items, instead of changing hand posture, users can touch down on the phone to drag. Users can execute commands from the audience by pointing the phone at the display and gesturing. In this case, the user performs flick gestures to pan the display to access content that is off the screen. Users can also pull content down onto their phones to view or edit locally. Once the object has been transferred, the user can resize and manipulate it locally. Users can perform the reverse gesture to push content to the shared display. Content sent to the shared display will initially appear as a package. The presenter can then tap to open it. Users can also take advantage of people tracking by pointing a phone at another user and then flicking up to share with them.
But that would be rude. What works better is to fall back on natural social protocol.
Users may want to briefly show an object to the group, the equivalent of holding up a piece of paper to share. By combining the phone's accelerometers with skeletal tracking, users can hold up the phone to transiently share. The presenter can tear off the shared content to make it a permanent part of the display. Pointing at the shared display specifies what to transfer and also puts the laptop into gesture mode. The user can then swipe down on the location they would like to place an object. The user then performs a reverse gesture to share their work with the group. In this case, no presenter is present at the display, so the package opens implicitly. We automatically split the display in place when multiple presenters are present to give each user a separate view of the same underlying content. We have presented CodeSpace, a system for supporting co-located, small group developer meetings by democratizing access, control, and sharing of information across multiple devices and shared displays.
Well, that about wraps it up. Thanks very much for your attention, and I'd be glad to take any questions you might have.
In local time in Seattle. Welcome to the call, Ken, and again, congratulations from all of us, the whole ISS and team and conference attendees as well. We do have a bit of a Q&A session prepared to have a bit of a conversation with Ken about the work and also the impact on work since then. We start with a few panelists we invited to join us for a few questions. That's Raymond Duxeld, Frederick Broody joined as well, and Jean van der Donk and Sylvain Malaka also joined the panel. And we'll start with these questions, but we also have a channel in Discord. You'll find this under the ISS plenary session. You find an entry for 10-year Impact Award session. And so you can post your questions there, and we'll make sure to integrate them in the question session as well. So yeah, that's how we continue. So I will just start by handing over to Raymond for the first question about the work. So over to you, Raymond.
Thanks a lot, Nick. And yeah, congratulations again for this great work. And my question is a little bit related to the fact that we are increasingly seeing lots of devices around us which are also combined sometimes. And yet, could you reason a bit more about why it is still difficult to see such systems like we have developed in research in reality, which really allow a seamless transition and a seamless interaction between heterogeneous devices and device ecologies? So maybe what is your point on that? Even so we have them physically available in our meeting rooms, for example, they are not used in this way like you proposed it in your work yet.
Yeah, I mean, it's one of those things where, you know, it's kind of any innovation always takes about 10 to 20 years to actually make it to the mainstream. Like even something is, you know, we think of the mouse as being very simple now, right? But from, you know, the mother of all demos to when like, you know, everyone had this in a GUI was, you know, at least 20 years. So this is, you know, it falls into that trend. More generally, I think this notion of like, why aren't things like in this video? Like, I mean, yeah, this is from 10 years ago. Like, why isn't this, you know, just in every operating system now? There's a lot of very hairy, you know, systems and security questions that make that difficult, because you're talking about sharing running program state across multiple, you know, possibly even different operating systems, multiple devices, having different interactions that span the bezel, right? The bezel is kind of this abstraction that traps us. You know, we currently have a project going in Microsoft Research looking at exactly this question. So we're trying to actually address this. It's certainly not easy. We published a paper at WIST on the surface fleet system, which is kind of the, you know, I would just say it's the tip of the iceberg in addressing this. And the basic, you know, thought there is that if you have some program abstractions that let you run a piece, have an actively running program where shared state can just be passed from device to device, as if it's just any other resource like memory or disk or, you know, file IO, that kind of thing. You know, the device should just be one of these abstractions at the operating system level. So we're not there yet, and there's some, you know, distributed systems are actually, you know, extremely hard and technically, you know, involved to do correctly, as I'm sure many in this audience appreciate.
Thanks a lot.
Thanks, Raymond and Ken. I would next hand over to Frederick Broody, who had a particular question about the social protocols and the kind of social gestures as well used in the work, which I'm also quite intrigued by. So I hand over to Frederick for the next question.
Yeah, hi Ken, and congratulations on the award. So yeah, as Nick mentioned. As mentioned, I'm also really intrigued about the social protocols that you discussed in the paper, and also that you mentioned in the video earlier. And in this case, it was like that people didn't like to be pointed at. And I think with these increasingly multi-device interfaces with augmented reality and so on, I think we need some form of a vocabulary or of a boundary or something for these gestures. And there are a lot of different ways for creating the gestures, and one is to do gesture elicitation studies. But for studies or for elicitation studies on the room scale for collaborative gestures, they might also be biased by the interactions we know from a computer, so the mouse pointers, and that's, I assume, where your pointing came from, or the windows we have. But my question really is, how can we create this gesture vocabulary, but also at the same time, how do we ensure that it is respective of people's social boundaries and of people's need for intimacy and privacy?
Yeah, really good question. And this is something I've thought about a lot. Yeah, like at the time we did this work, we basically had this capability where we could detect people and devices and so forth. And so we had this general notion of like, okay, you can point at things, then you do this gesture, and it transfers to that person or object. And so, of course, in terms of what the code was doing, it was very easy just to substitute, device A for person A, right? But when you point at people, like as you saw in the video, yeah, I mean, Rob DeLine did some good acting to kind of like nod and go along with it. But when we tested that, like it was sort of this bimodal, reaction in terms of the feedback that you'll see in the paper, where several people were like, this is just not socially appropriate, and I agree, which is why I put that little editorial remark in the paper, because as in many papers over, I'm sure we're all familiar with this. The video was shot before the feedback for the study was done, right? So, so we didn't have that part in the video. Yeah, I mean, more globally, like in terms of how do you get insights into like which of these are appropriate? Part of this is just understanding sociology and sort of the everyday interactions that people have. And this is something that and I'm not a sociologist, right? So take this with a grain of salt, but I've sort of trained myself to pay attention to these things and just sort of my everyday interactions with people. And sort of these little, seen but unnoticed things that people do, just in terms of, body posture, even like is someone getting closer or further away, but also, what people do with their hands. What are they doing with the objects that are the focus of conversation? So for example, like right now, if I had some paper, I mentioned the surface sleep paper, for example, in my last question, to actually, dig that on my file system and share it with you and get it up in the call here, that would probably take me about 30 seconds. Where if I just had it printed out here, I could just say like, hey, look, here's the thing, right? So, I mean, that's literally like, it's like a 2-second or sub-second sharing interaction in this Teams call, right? Yet in current practice with these modes and so forth, it's so tedious and so difficult to do that. So, things like behaviors like this, that is a sociologically rooted behavior. So things like that are really interesting. The other sort of caveat is that, I've found, and perhaps I haven't found the right source, but in the sociological literature, they have there's a lot of discussion about how people orient themselves to one another, physical distancing, not just because of coronavirus, but because of social reasons, right? These kind of like little huddles that people form at cocktail parties, for example. But there's really not much, you will find mention of it occasionally, but there's not much focus on the actual objects or the artifacts that are the focus of the conversation. And so from here, like actually some of the best, insights are from the HCI literature, like the classic, Luff and Heath paper on mobility and collaboration, which introduced this notion of micromobility, which is, this kind of behavior. Like I can just show you the thing. So we're very interested in co-opting those sort of things. So, to me, it's like a bit of a misnomer even to call those gestures. They're just part of the everyday social fabric. And one of the real challenges of co-opting those things is that they also play this role in human-human communication, of course, right? So if something like, lift device to, 77 degrees means some special thing in the system, that's no longer part of the social vocabulary, right? So you need to be careful of that as well. And there's been some great papers, the title's escaping me at the moment, but on this sort of socio-spatial literacy that address things like that. So it's a really interesting challenge, and I have some active projects kind of exploring things like that, but I don't really have the answers yet.
Thank you, Ken, for great thoughts on how these, collaborative and social acceptance can be. I have a question here from Sylvain Malacria on a similar thread about more specifically meetings. amongst multi-developers. So Sylvain cannot be in the panel as of right now, but he had a question. So first, congratulating on the work. This is great work. And even in this time where physical meetings appear to be a fantasy, we're all stuck at home, reflecting on your work makes him very excited to have physical meetings again. So it was inspiring to him and wants to go back in the lab. So then he goes about saying that this is something that you probably investigated in your work since 2011, but all coder meetings that he has recently attended were full of coders being heavily active on their own laptops, stuck with their own little screen, still participating in the meeting, but also producing a lot of content on their own, isolated from the rest of the room, because it's barely, you know, what we happen to do. So he wonders if you have thoughts on how you think the coder meetings will be shaped in the future, mostly using personal devices articulated around public displays, especially with the advances at Microsoft, where you have like large screens and like more and more interaction and interesting collaborative capability there. Can you share your thoughts on how you envision that our future to be if we can get together in the same room again?
Yeah, I certainly hope it won't be too much longer now, but I don't know, reality may intrude on that thought. Yeah, I mean, I'm not quite sure how to address this one. There's a lot of things that come into play. Like there is this, like, I mean, even when you're walking around in everyday life, like everyone's kind of like, you know, the scene in the street is not, you know, people looking around and talking to each other, but it's like, you know, everyone's like in their phones, right? So in a sense, these devices have brought us together, but in another sense, they've isolated us at the same time, where we kind of cocoon in these little digital worlds. So I don't have a great answer to that one. It's clearly something that's causing, you know, great societal harm at this point. You know, in terms of also, you know, erosion of democracy and so forth. So we're seeing some of the downsides of this. So, you know, it kind of, you know, reminds us to be mindful of, you know, Kranzberg's law, for example, where, you know, technology isn't inherently good, it isn't inherently bad, but it's not neutral either, and we need to, you know, design with that in mind. Let's see, the other aspect is sort of this, you know, semi-public, you know, fixed feature of the large display. And yes, in this paper, like the large display was sort of the focus of the encounter, right? This you know, sort of small circle of people had a large display as the focus. This was sort of a nice place to put the Kinect sensing that we used in this paper, right? So that's an example where you can do this sort of added spatial sensing and it makes sense. You know, it wouldn't make sense to put a Kinect on your mobile phone in 2011. You know, that's actually changing very rapidly now, right? So we see technologies like LiDAR and the Google Soli technology, and or even like capacitive sensing that can sort of go above the screen as well. These are very exciting, you know, new technologies to me that, again, they present opportunities. I guess there's also opportunities to be invasive of privacy if like they involve cameras that are always on, for example. These are other issues that we need to think about. You know, how can we have these kind of interactions with sort of less pervasive sensing? I think there's actually tremendous opportunity to have creative interaction design that can sort of paper over, you know, a lack of sensing in many cases. So I'm really intrigued by this thought that, you know, maybe with very limited sensing, you can do a lot of these kinds of interactions, and then just simple things like, you know, maybe it's just a pinch across two screens, right? That's giving you information about the spatial relationship between two devices, but there's no actual, you know, device sensing there. So things like that, you know, I think with appropriate design could get us a long way, and maybe are the sweet spot for these kind of interactions, even though it is still fun to play with these old Kinect cameras and sort of the next generation that's coming along.
Yeah, thanks, Ken. This is I very much agree. Like if the sensing can, you know, capture how we act as human beings, and that's what the devices capture, and we can be more human again, and have the devices be part of our loop rather than the opposite way around. I think. Yeah.
Maybe one more little point on that. Like another thing that's a real challenge is that the sensing sort of it talks about these different reference frames, right? So a lot of what we've talked about are, you know, it's often like device-centric sensing, right? Or it's relative to the frame reference of the Kinect camera, right? So sometimes you want that. Sometimes you want the room, you know, reference frame. Sometimes you want to know what's going on around the device, but you also want to know the person, the egocentric coordinate systems, and how we space to people. And it's often hard to sense all of these reference frames at the same time, and it's also very hard to reconcile them with one another. So that's sort of another big problem that we have. And even like in, when people talk about things like in this video, we mentioned the posture of the device, right? Like even that one term, it's like, I guess it's partly my fault because I have used it in several different ways in papers over the years, but it takes on different meanings, right? So is it the person's body posture relative to the display? Is it the actual, posture, the orientation of the device, or is it, some third thing in between those two? We need to actually sense and understand all of those or have ways of reasoning about them. And we're even lacking that vocabulary, I would say, in the literature in general.
Thanks, Ken. So speaking about sensing and interaction, Jean has a few questions about the combination of touch and air. Jean, do you want to take over?
Yes, okay. Can you hear me?
Yes, we can.
Okay, I can. Congratulations again for this wonderful prize, which is really deserved.
Thank you.
What do you think about incorporating a ring device in the loop of air plus touch gestures? For instance, if I can point to a target with my finger and select an item from a menu using a ring device, so as to get air plus touch plus ring, or ring plus touch plus air, or whatever combination you like. What do you think about that? Thank you very much.
I think it's potentially an interesting direction. I haven't explored using a ring in that role specifically, but we have done things along those lines using like a wearable, like kind of fitness band or watch, right? Because given where we are with embedded sensing and devices these days, like kind of accelerometer, gyro plus magnetometer is just, you basically get that like for free on the die for your CPU that's in your little device anyway, right? So almost all devices have that sensing capability. And once you have that, you can do quite a bit with just that using these little sensor tricks. So for example, Andy Wilson has done work on if you have depth camera sensing and you have either a ring or wearable, and you can sort of see that moving in the image, you can correlate that with the actual sensor trace you're getting from the accelerometer and figure out like, oh, okay, I see a device moving and I know it's device X because the motions are exactly corresponding. So that's one sort of trick you can do. Another is you can actually, if you're combining these wearables with touch interactions, at the moment I go up and I touch the screen, that touch actually imparts a vibration in the screen as well as in your hand. You can actually see that signal of like the little thump when you touch the display. So again, that gives you a little point where you can correlate those two and say, oh, okay, now I know that it's a particular individual and even which hand of that individual is touching the display because the wearable gives you something to coordinate with there. So these are kind of like interesting ways you can bring, again, like this sort of perspective of there's multiple devices that are cooperating to realize these experiences. I think that's where there's a lot of interesting things that can be done in terms of complementary sensor signals across, not only our common devices and phones and tablets, but wearables and other, it might just be little mote sensors that are kind of scattered about the environment, giving you different signals.
Okay, thank you very much. That makes sense. I was particularly considering the ring device because I can then combine the pointing and rolling the device on my finger, for instance, for another, so that I do not need to change from one perspective to another or from one device to another.
Yeah, that's a good consideration too. I mean, you're kind of hinting at another issue, which, I mean, you saw it a bit in the video I just showed, which is, when you have these hand gestures, like you hold it up and then it starts tracking the cursor. There's sort of there's a state change that's involved there, right? So I'm just talking, waving my hands around. I don't want these cursors going all over the screen, right? So it has to be this sort of, I do some particular gesture, there's a little timeout that happens, and then the interaction happens, right? So you need something to, not just track an XYZ position, but actually, have different states of that where I'm either in a pointing mode or a gesturing mode or a dragging mode and these sort of things. So those state transitions are the real gotcha in a lot of these interactions, because really nobody wants to go and hold their hand for 3 seconds and then have the interaction start. If you ever use the original Kinect on the Xbox, like you'll know what I mean in terms of like, typing text and like going through the menus. It was just, it was not really the best way to do that. So something simple like, just, touching your ring, for example, that gives you that state transition and it gives you that vocabulary that's more similar to what we have with touch screens, which sense, of course, when your finger touches the display and not just the location of the finger.
Okay, thank you very much again and congratulations.
Thank you.
All right. Thanks so much to everyone already joining in. Again, as a reminder, if you would like to ask Ken or essentially also anyone on the panel, I guess, any questions, you can go to Discord and ask questions, but we have a few more. And first, I would again hand over to Raymond for a question. Please go ahead.
Yeah, thanks a lot, Nick. I mean, this is a related question to Jean's one, and this is concerned about the different gestures or interaction techniques you're using. I think in this research and also in follow-up research, people have suggested lots of different ways of how to interact across different devices in device ecologies. And what do you think about the typical thing like standard interaction? So is there something like a standard interaction, or in other words, doesn't the variety of different gestures somehow hinders a widespread application of such interactions in cross-device or multi-display environments?
Yeah, so I mean, I think it's pretty clear that we haven't really settled on a universal vocabulary of what are these cross-device gestures and interactions yet. And there's at least two major different buckets of them that I would point out. Like one is sort of like these pointing type things that we were just talking about, like with using the ring to sort of control a cursor. Maybe you touch it and that gives you a drag state, right? So those are sort of more intentional foregrounded interactions. There's a whole nother class of which is using the same signals as a background contextual sensing cue. And these sort of things are, like for the examples in the video I showed are like, oh, two people walk up to the display, so it goes to the split screen state, right? That's a very different type of interaction. And so I think, partly some of the confusion and some of the apparent, sort of heterogeneity of these gestures is that it's not clear which gestures belong in which of those two buckets, foreground or background, and how exactly to best separate those two. Because it's very clear that this kind of sensing, often if you can have a reactive environment that can sense, the approach of someone to the computer, like, my screen should wake up, it should bring up the, my password, like that kind of thing. Even those experiences are not, very, very commonplace these days. I mean, I guess we do have things like, oh, you look at your phone and it signs you in, right? So we're starting to get there. Often these things do first appear in the mobile world. It's kind of, what we've seen again and again over the years. But gradually that should bleed out to these other clients as well. Of course, it also ends up being this really interesting multiple device coordination problem, right? Because if every computer has this property and if you walk down the hall and like every computer is like signing in as you walk by it, that might not be the best thing either, right? So, or another example is like the echo kind of things you get if you join like a Zoom call from multiple devices, right? They don't necessarily always coordinate the best, so you get these like feedback loops and so forth. And the devices, they should know this. They should know that they're co-located or that they're observing similar things. But we're really not there yet in terms of systems that actually work this way. So those are some of the challenges I see. So yeah, in a sense, it's kind of like we're at the very early like kind of Xerox star days of designing the common vocabulary of these cross-device interactions, and we don't really have the Xerox star demo itself yet, but we have some ideas of what pieces are there. But we're still 10, 20 years from like here's the here's the Macintosh version of that.
Yeah. And maybe it's just a short follow-up. Of course, there's this trade-off between the more natural a gesture and interaction is, the more likely it is also that you involuntarily issue such a gesture or do it. You mentioned this example of proximity or movement or so. Of course, if you can use it for interaction, it's great, but this, of course, also happens quite naturally and is perhaps not intended as interaction. So this is always this trade-off between these really beautiful gestures that they can be involuntarily issued as well. Just as a comment.
Yeah, I absolutely agree.
Thank you. We have next a question that Frederick wanted to ask about the move to other spaces and also the kind of change from outside in tracking to inside out. And so I just hand over to Frederick for a question that links to some of the things that were already mentioned. Thanks, Frederick.
Yeah, it's kind of like it connects a bit to what you said about the devices should know their context, and devices are increasingly doing inside-out tracking. And in your example with CodeSpace, it was to support development meetings in a work environment, in an instrumented room. But we're now seeing more and more devices and tracking infrastructure of all sorts, and also, as I mentioned, like in with inside-out tracking. And devices might even know their context. And people have more devices at home. So I was wondering what you think about opportunities for home space or something like code space, but at home in a much less structured environment, in a much more cluttered area, and so on.
Yeah, I absolutely agree. It's funny, we're all working at home, so I guess, home space is code space these days for many of us. Yeah, so it gets quite interesting. Like, yeah, so I mean, this is kind of like the dirty secret of every, demo, like, code space. Like the group together system that Nick and I did, a couple of years later had exactly the same quality, which is, the second you walk out of the view frustum of the Connect, like all the magic kind of ends there, right? And we've explored some little hacks and tricks to try to extend that, but the fact is that the second you don't have this spatial depth sensing, like none of the interactions work, right? And I've always found that in a sense it's really great to be able to explore these kind of possibilities and kind of give you little hints of what the future could be. But by the same token, like we all know that many of these demos, like the second you walk outside the lab, the door to the lab, they just you don't have these experiences anymore. So how do we get there? How do we actually? And this doesn't seem like it's like oh, in 10 years, like there'll be these sensors everywhere. Like there's always going to be environments where you walk outside, you're in you're hiking up a mountain or something, right? There's not a Connect sensor on the tree, right? So it's sort of an inherent thing we're going to have to figure out how to deal with. And so again, this gets back to this idea of well, how can you do these kind of experiences with very lo-fi sensing or using clever interaction design to kind of cover over those seams. So this notion of but by the same token, there could be many contexts where you do have this sort of dense sensing where more enhanced capabilities are possible. So how do you do this handoff between a lower fidelity sensing to like this environment where maybe you can do more and then back again and make those transitions really smooth and natural? To me, it feels like there's not there's some examples I could dig through my my bibliography and find point to a couple papers, but it really hasn't been a large body of work that addresses that. How do you move back and forth between these different sensing environments in ways that make sense to people? And so I'd love to see more work exploring that theme and what kind of feedback, what kind of interaction techniques, what kind of design tricks can you do to actually fake spatial sensing when you don't have it.
And I guess also the question is like, do we always need spatial sensing, or can we create some of those experiences without the tracking, whether internal or external, as you said, like on top of a mountain without a Connect or something?
Right. I mean, I often like to look for little existence proofs that these kinds of things are possible, right? So one, for example, that we've all likely experienced is if you have more than one monitor on your system, this little dialogue where you go in and you tell it once, like, okay, monitor A is here and monitor B is there, and then I got a third one down here, right? And basically, once you do that one time, as long as you don't change your setup, your cursor can float between all three of those screens, right? Which are, in a sense, they're different devices. They happen to be plugged into the same box and running on the same operating system. But in principle, there's no reason you shouldn't be able to do exactly that, across any device ecology. Of course, then you lose the dynamic nature of it, right? So maybe there's even things like that where maybe you just define a couple of your setups that you use commonly. The devices can sense which setup they're in, and then it just switches between those. So it's sort of a manual step in the loop there. And then over time you look for ways to reduce that friction. So maybe there are some simple things like like the idea of a pinch gesture across two screens. That's like a little bit more lightweight than going into some multi-monitor dialogue setup. So maybe that's something you can do when you do a different setup. You do your little pinch gesture, it knows you're in a different configuration, and then you roll. So it seems like we need things like that going forward that let us have that flexibility. But yeah, maybe without a Connect on every device that we own.
That's brilliant. I can't wait to explore many of these scenarios for sure, many of these techniques. We have two more questions. I think there's one from Joachim, and then Raymond will ask the last questions after that. So I hand over to Joachim. Joachim, you're muted at the moment.
Yeah, ich weiß. So Ken, thanks, excellent. So these things take some time to get hold of. You were suggesting that you think that this will these techniques, multi-device, context change type of interactions will take even longer to get old than the 20 years it took from Engelbart's Mother of All Demos until we had all of the mouse in our desktop, and now we hate these mice. And Ervoje Benko, in his other presentation, his keynote, he suggested that 20 years, 25 years, if you look at the time it took from Bill Buxton's experiences with multi-touch gestures and sensing until we got the iPhone, it was more or less also something like 20 years. So why are you so my question is really two. The first part is, why are you so skeptical about the next 10 years? I know that the future looks very bleak now, but we could use with a moderate modicum of optimism. And the second part of my question is, maybe what we need is more than, say, 5G. Okay, let me put just this stupid buzzword in front of us. Maybe what we need is a new discipline of interaction design, and that's what we have not got yet.
Yeah, so those are both excellent questions. So first off, I would say that I actually don't feel skeptical with the next 10 years at all. Other than like erosion of democracies that we're seeing across the world. But in terms of technology and where we're going, I mean, I think in a sense, it's like the fact that this is already a 10-year impact award is kind of hinting that we're at least halfway down that curve to where it really will be feasible for this to go big, and maybe we're even a bit ahead of that, because there was of course there was work before our paper as well, as is often the case. So I actually think we're closer than 20 years to this becoming more mainstream. As I said, I think there's some very difficult systems, distributed systems issues to actually make this real, right? So what does it really mean to integrate and have running state that can move, migrate easily from device to device, or bring complementary devices together where they're essentially running as part of the same program. That's something that we're tackling, but it's really not there yet in terms of like, is this something that we would ship in Windows tomorrow? Like, well, no, right? But it's something that I see as being a likely future. And more to the point, you mentioned 5G, which is, yeah, I mean, to me, it's more than a buzzword. I think this is sort of a long-term trend, right? Because we've seen, Moore's law is basically dead, right? We aren't really seeing rapid advances in CPU price performance anymore. But if you look at what's happening in networking and storage, those are growing, astronomically. And 5G is sort of the next, it's just starting now. Like, yes, if you buy a device right now, are you going to get good 5G? No. But this is like a huge investment by the telecom and technical sectors, and so it's going to happen eventually, right? And if you look at like what, if you have like a 10 gigabit throughput at low latency, right? That totally changes like how you think about these interactive systems. So in a sense, like, this notion of like, oh, a device is just like some other resource that the operating system manages, like that starts to make a lot of sense suddenly when you can just be moving huge amounts of data around at low latencies across multiple devices, and across not even just your own. It might be maybe even in this call, I can be running some program, I can be typing away my paper, and instead of having you go into some overleaf thing on a website, I just basically like pass you my running program, and now you can go to work. I think that kind of thing is going to become very real. So that's where we're heading, and so that gives me a lot of optimism, actually, and it really speaks to anytime you sort of have an order of magnitude of change like that, it just completely changes what is possible in terms of even how we conceive of interfaces. And I don't think the community has really wrapped its head around that. It's a technology change, but it's also going to be a human change and an activity change, and the type of tasks people want to do change. I think we need to understand that, and I think it's going to be a huge area, 5 to 10 years from now.
Indeed. So maybe I would like to just say another comment is that congratulations on your tenure, and hope that your next tenure sees us there.
Thanks very much. I appreciate it.
Wonderful. All right, so we just have one question remaining from Raymond to close up. It also continues from what we just talked about, and is a question about what comes next. So over to you, Raymond.
Yeah, thanks a lot. Yeah, I think I also believe it will be less than 20 years in this case, because we have the devices already. And yes, we have the connectivity as well. So these are really conditions for that. Of course, we still have to do something on the interaction side, as we just discussed. But really, I think the application side is still a little bit unclear to me. So I think in your paper, you chose a great application. So it was really good to have this example of collaboration. But sometimes we are a little bit superficially saying, oh yeah, people are collaborating, and indeed we do in real life. But what application areas or so, what killer applications do you envision for the future, where such device ecologies with a large display and maybe several smaller displays will really take off in the future?
Yeah, I mean, to be perfectly honest, I don't usually like the notion of there being a killer app for something.
Not killer, but many enabling applications which really would make sense, and where this kind of setup would make sense a lot, and where people really engage in using that. That's better to say so.
Yeah. So, but yeah, just to continue the thought, like and the reason I don't really like, sort of the killer app or the focus app perspective is that, it tends to say like, oh, if you just come up with one magical scenario, it'll make all of this happen, right? But where I really think, where the magic happens is when it's pervasive, and maybe even the app is the sort of the wrong level to think about it on. Like, so for example, like, I'm running, maybe I'm running a PowerPoint presentation or something here, right? If I can actually, grab the sort of the toolbar and my controls for that and actually pass them off to someone else. Like now I could have Nick, forward my slides for me, right? While I continue to focus on the social interaction, right? So it might be that the granularity is even less than at the application level. So little scenarios like that, if those become pervasive, and like if you imagine that, essentially every little widget or every, tile in this Zoom call is essentially a running, its own independent executable that I can pass off to other devices, it starts to make some really, magical things happen. So, maybe I don't like this, 16 tile format for this call. Like maybe, Raymond has a lot of good questions. Maybe I want to take your tile and drag you off onto my mobile device or my laptop, right? So now you have a dedicated space. So when I go and look at Raymond's question, it'll be clear that I'm addressing it to you, and the rest of the audience can see that as well, right? So those are the kind of things I'm thinking about are, that's sort of the killer app. Like that's sort of, it's actually the unbundling of the application and letting it spread out across multiple devices that are spatially located. And it could be co-located. It could be also a remote locale, like as in this remote work situation, is really giving us a lot of insights these days. That's where I think the magic will be, and exactly how to harness that for totally new types of applications that we haven't even thought of yet. Like that's what I'm very excited about. And I don't, if I had the silver bullet there, I would certainly give it away here, but but I don't, right? But I think there's really exciting things there. My research spider sense says, this is going to be a major transformation, and there's going to be some amazing things there. So yeah, I hope all of you will take some inspiration from my ramblings here and actually go do something cool and coherent. So thanks very much.
Great, thanks a lot.
It's a wonderful ending to our conversation, Ken. I really enjoyed the conversation with all panelists. So I want to thank Ken again for joining us, and congratulations again to you and the co-authors for the award. I also want to quickly thank our 4 panelists, Raymond, Frederick, Jean, and Sylvain, for joining us for this conversation. Thank you, everyone. We're at the end of our award session, and we now have 2 more things remaining. There's the closing keynote, and after that, the closing remarks. So please join us later. And I don't have this. I think we have a 30-minute break right now.
Yes, we do.
Correct?